Okay, should we start? I am Carlos Carrasco. I come from IESE Business School, which is a business school here in Barcelona. And for some communication problems, I have prepared my presentation in Spanish, but I can translate it into English on the fly. So anybody needs that I do my presentation in English? Or yeah, okay, then I will do it in English. And I will start with a sentence which is coming from this book, which is a famous book in the business domain, which states that thanks to technology, the distance or even language doesn't matter anymore. Because thanks to technology and globalization, we are much more connected, so the distance doesn't matter. The problem here is that, do you know this guy, by the way? No? Nobody knows him? He's Math, which is an MIT influencer, which is also one of the top 50 social media influencers in the world, and he works as the UK head of global media at the Ogilvy Group. And he has something related to this woman. Do you know her? No? Nobody from Germany? No? She is Cornelia, and she is a German politician. And Cornelia sent this letter to Math right after the Brexit referendum. And she was offering him to move from London to Berlin and offered him some space to put his company and some fiscal advantages to move from the UK to Berlin. So basically, Math wrote a post on LinkedIn and started to ask, why, if we have emails, Skype, Facebook, Dropbox, or things like mobile phones, smartphones, and laptops, or what, even if, why are we moving this way if we have technologies like big data or the Internet of Things? And he asked, why aren't we all working from home? Why aren't we living in the middle of nowhere, in the middle of nature, and just working from home, or even following this conference from home? The reality is that the world is moving towards the opposite direction. For the first time in history, we have more people living in cities than living in the countryside. And cities account for more than 80% of the GDP of the world. And it will increase. So we are, as humanity, we are moving towards cities instead of moving towards the rural world. And this is good from the economic and social point of view, but also it creates some challenges. For example, we have energetical challenges, social challenges, or economic challenges that we need to solve if we want to survive as human beings at least in this planet. So how many of you have faced situations like this in your city or in any city that you have traveled? Yeah, every day. And what about this? Also things like this. And what about paperwork? Every time you need to talk to the city council or the public administration, you need to do a lot of paperwork. Okay, then what about this? How many of you have used Google? Yeah. And what about Netflix? And Amazon? Yeah, a lot of you. Okay, then what is the main difference between these two kinds of organizations, between city councils and Google, Netflix, or Amazon? How are they approaching their problems and their challenges? There is one main difference here. Sorry? Private? Yeah, but you also have a lot of private companies which are a huge disaster. So, and also some city councils that are really good on their job. So, the main difference here is that they are data-driven organizations. And this is important because you cannot manage what you cannot measure. And here we are having a problem with cities that are not collecting data, or they have a lot of data, but they are not analyzing it. So always, when you're facing a problem, think about what would Amazon do if they would face this same problem. And, okay, you would say, yeah, Amazon, Google, or Netflix, they have a lot of data, and in contrast, cities, they don't have that much data. Well, this is absolutely false. They have a lot of data. Think about, for example, every citizen, every city council has a lot of information of each citizen, of each company, which is based on the city. They also, the public sector has a lot of information about it. Every economic transaction, when you pay with a credit card, can be analyzed to understand the economic activity of the city. Every vehicle which is moving around the city can be also analyzed. Every email that is sent to the city council or from the city council can also be analyzed. Even every tree in a city has a lot of information to be analyzed. Or every emergency call to the city council can be analyzed to understand what is going on in the city, or every new restaurant that is opening is generating a lot of data. So here is when comes data science. And I'm going to show you some examples on how are we helping cities to make better decisions based on data. And I'm going to start with a small comparison between cities and astrophysics, which is, do you know what is this? Can you have a guess? What do they show? Wi-Fi points? No? No? Okay, each point here is a shop in Madrid. So here you can see the shops in Madrid and how are they clustered in the city center. And I made a funny exercise, which was uploading this data on Google and asking Google for similar images. And Google returned me all these images. And I started to think, okay, what if we try to understand, to analyze retail activity in cities as we were analyzing galaxies? Which drove me to this question, which is, are cities or the economic activity that is taking place in cities comparable to galaxies? So what do we need to understand or to study galaxies? First of all, we need huge telescopes to see what is going on, to create maps of galaxies, maps of stars. Then we need a periodic table of the simple elements of the universe. And then we need the electromagnetic spectrum to see which elements are in each galaxy in order to understand them. So for city, as a summary, so we need telescopes, the elements of the periodic table, and then the electromagnetic spectrum. And for cities, what do we need to understand the commercial activity in cities? First of all, we need a map of the location of these activities. Then we need a table to categorize each commercial activity into simple elements. And then we need indicators to understand how these categories match with each other, how they cluster together, or how they don't cluster together. So basically, we need something similar to what we need to understand galaxies. We need a map of what is going on, of retail activity, or a map of stars and galaxies. We need a periodic table to categorize things into simple elements. And then we need indicators to aggregate these simple elements. And we are facing a similar problem when we try to analyze those two kind of issues, which is we cannot wait to analyze. We cannot wait enough to see how a galaxy evolves. So it will take thousands of millions of times to see how this galaxy is moving and how it's evolving. So the diachronic comparison is not an option for galaxies. Now think about cities. In cities, we are facing the same problem. We don't have enough time to see how cities are evolving. They take thousands of times or hundreds of times to change. So, as in galaxies, we don't have this option. So, what we need to do is comparing galaxies and cities in a synchronous way. And think about how the center of a galaxy works. It has a massive attraction power. It has also a huge and a massive rejection power. And also it has a huge rotational speed. And if you think about the commercial activity in cities, you will notice that they are not placed randomly across the city. And they are not placed regularly in the city. They are clustered in specific areas of a city. So here you can see the number of commercial activities in the metropolitan area of Barcelona. And as you can see, there is a clear and a huge center which is attracting everything that is going on in the metropolitan area. And then we have smaller cities with also they have retail activity, but not as much as in Barcelona. So the city center is also attracting massively the economic activity. At the same time, is rejecting massively some of these activities. Think about, for example, food stores or supermarkets in Passeig de Gràcia or in Portal de l'Àngel. You will not find anything selling food, at least for taking at home in a city center. And they are also rotating on a massive speed, which is a lot of shops closing, opening new ones, new restaurants, and closing existing restaurants, and so on. Now think about, do you know what is this? Yeah, this is l'Eixample of Barcelona, and each point? People, yeah. This is people living in l'Eixample de Barcelona, which was an exercise that I did using the open data dataset that is available at the open data portal of Barcelona City Council. And they gave us a table with the number of citizens for each block in the city. And you can say, okay, I can take this data and make a visualization like this, which is nice, but not that nice. Because, yeah, I can see how many people is living around the city. But then I had an idea, which was, okay, I know for each block how many people is living there. What if instead of using these blocks, I put a point inside each block according to the data which is on the open data portal. And at the end, what you get is a map like this, which is made of more than 1.6 million points, which are the inhabitants in Barcelona. And with this visualization, you can clearly see areas which are not so much populated, like the city center, or Poblenou, which is an industrial area in the city for those who are not from Barcelona. And this kind of visualization is much more useful than the typical table or than the typical map that the City Council was using. Then another example of how to analyze cities and understand how cities work, which is using something similar to what Google Maps do when you try to find the easiest way or the fastest way to move from one point to the other. First of all, Google asks you for your location, then it asks you for your destination, and it calculates the shortest path between these 2 points using an algorithm which is basically a network. It creates a network of a city and calculates the shortest path between point A and point B. So, and then we can calculate different centrality measures to see how different streets are more important than others. The problem here is that you can do an analysis of a network on the vacuum, but if you create a network with a city, these nodes and the edges are tied to a specific location, which allows you to do more complex analysis using the geometry of the city, which drives us to different formulas to calculate much more centralities than in typical network analysis. For example, this is the result of one of the network analyses in Barcelona. I will show you more analysis later, but think about how Google Maps work, which is basically you have a starting point, a destination point, and here you have the vector of instructions that you need to follow, which is, first of all, turn right, then 1 street on the left, 3 to the right, 2 to the left, 1 to the right, and so on, to arrive to your destination following the shortest path in this city. But we have other definitions for what is the shortest route to move from point A to point B. Think about, for example, if you are moving around a city that you don't know, it may be hard to follow a path like this, which you need to remember a lot of things. Instead, what if we take the simplest path, which is defined by the route that takes less vector items, which is this one, where you just need to remember, okay, I have to move 6 streets to the right and then 3 to the left. And that leads us to a question which was, okay, when people is moving around a city, are they following the shortest path in meters or in kilometers, or are they following the angular shortest path, which has a lower cognitive weight, so it's easier to remember? And here you can see why it's much easier to remember. So here you just need to remember 2 things on the red path and a lot of things on the green path, even that the green is the shortest route from point A to point B. So what we did was taking a vector map of the city in Barcelona with all their streets. Then we collected this same information for 20 cities around the world with all their streets, which are more than 1.5 million streets in these 20 cities. Then we collected GPS tracks for all these cities, so to see how people is moving around a city. We did the same for the same 20 cities, which are more than 22 million GPS points in all these cities. And we had a problem, which is GPS points have a lot of errors. So they have a margin of error, so they are not detecting your exact location, which means that you have a map like this, or like this if you are using the points. And we needed to match each point to the closest street to then analyze the correlation between centrality measures and how people is moving around a city. And this is when it comes the hidden Markov chains and the map matching problem. So here we are facing a problem where we know some of the measures and others, but we don't know this GPS track or this GPS point to which street it belongs. So we applied this model, which at the end, what it makes is, okay, detect the closest street for each point, and then match this point to this street segment, then go to the next point and calculate the probability that the previous point was based on this street based on the location of the second point. So the algorithm goes forward and then it goes backward to see if it matches the shortest path between the GPS points and the street assigned to each point. So at the end, what we get is a map like this based on different centrality measures. For those who know Barcelona, you will notice that these are the streets that are always full of traffic. And this is for a reason, which is that they are the shortest path between the rest of the streets in the city. So everybody goes there following the shortest path, which at the end, what we get is that it's not the shortest path, but the longest. But if we are moving rationally around the city, we will follow the shortest path. And then what we get also is a perfect match between the GPS traces and the street segments of each city. And with this, we can calculate the clustering of different cities to see how people is moving by vehicle or by walking, and how cities like Barcelona and Osaka, they appear together constantly across all the measures that we have calculated, which, by the way, this is a project made from students from the Big Data Master at La Salle, which you have seen the presentation from the previous speaker. And also, we can do things like analyzing things like this. Do you know what is this? Yeah, this is Barcelona. No. Each gray point is a retail activity in Barcelona, but we have two different data sets here. One for the gray points, which are the location of economic activities, and then another one, which is putting some points in green and some in red. Well, here what we can see is in red the location of bars in Barcelona, and in green the location of restaurants in Barcelona. So as you can see, we love to drink and eat here in Barcelona because we have a lot of restaurants and bars all around the city. And the thing is that the location of restaurants and bars is extremely correlated with network centrality, which is the measure that I have shown you before. So economic activity tends to be placed in central areas of cities. Also, another funny example, which is here we collected during 2 months the geolocated tweets in Barcelona and Madrid, and analyzed them also in Sevilla, Valencia, and Zaragoza, but I'm interested in what is going on here. Why do we have this peak around the 23rd of April in Barcelona and Madrid? What happened? It is from the last year, so it's not from this year. But what happened last year on the 23rd of April? Yeah, it's Sant Jordi in Catalonia, but yes, it was the Barça-Madrid match. So using external data like Twitter data, geolocated data from Twitter, you can see things like this. Also, another interesting study, this is not mine, this is the only one that is not mine from the presentation, but I said at the beginning of the conference that there is a lot of people saying that, okay, now that we have a lot of technology that allows us to talk with people from around the world, the geography or distance is dead. The reality is that it's not dead, it's even more alive than ever, which is shown by the people you follow on Twitter. So you tend to follow people who is closer to you in kilometers. And also, this is another funny example. Nobody from China here? No? Okay, and the conference is being recorded, which it may cause me problems when I go back to China, but I was in China last month, and I took this picture on Tiananmen Square, but I also took this other picture, which is here you can see a lot of cameras. And they have these cameras all around the city. They have a lot of cameras recording what is going on streets. And the funny thing is that I was invited by the Chinese government to see their technology, and they showed me this, which you may know from the news or newspaper, that they are applying facial recognition on the streets to analyze what people is doing. And here you can see different cameras on the street and the facial recognition software, and how this software is matching the faces that they are seeing on the streets with the ID card of each citizen. So they know exactly where each citizen is at any moment in the street. And here you have people that the system has not been able to match with an ID, which is mainly foreign people. And here you can see that I'm here and here in two different places in Beijing. So the system cannot match me with an ID, but still he is recording me. And he knows that I have been in this place, which I don't know to read Chinese, but this is a place, and this is another place. And he knows that I have been there. And they are collecting this data and analyzing all this data. Also think about a problem that we are facing in Barcelona. Here, for example, you have the location or the concentration, the density of hotels in Barcelona and hoods, which are the touristic apartments with a license. What if I ask you for the location of Airbnb apartments? Do you think the density looks more like this or like this? Who thinks the location looks more like the hotels? Or Airbnb apartments are more distributed around the city? First one? Okay, Airbnb is claiming that they are distributing tourism around the city. So neighborhoods that traditionally are not benefiting from tourism, thanks to Airbnb, now they can benefit from all this touristic activity in the city. But the city council was not so sure about this, but they don't have the data. So what I did was scraping the website of Airbnb and seeing the density of Airbnb apartments, which looks like this. So basically, the apartments of Airbnb, yeah, they have apartments all around the city, but when you look at the density, they are mainly located on Ciutat Bella, which is the old neighborhood, the old quarter of the city, around Sagrada Familia and around Gracia, which explains a lot of the problems, especially with neighbors, that Barcelona is facing. More funny things from the scraping of Airbnb, which is the top 10 hosts in Barcelona, which are number one, Oscar and Diego, who are managing 77 apartments in Barcelona. Because another interesting thing to analyze is that Airbnb claims that, okay, with our platform, we are helping people to pay their rent or their mortgage and or even their vacations and so on. But the thing is, what if you have people with such amount of apartments in Airbnb, are they putting all these apartments in Airbnb to pay for the rent of 77 flats? So we asked, okay, let's see if this is an apartment where somebody is living, and okay, they can put it on Airbnb when they leave for vacations or for the weekend, and they get extra money and so on, which is what Airbnb is claiming. But the reality is that here you have the days during the year and the availability for renting the apartments in Airbnb for Barcelona. So what you can see here is that the majority of the apartments are available the whole year, which means that there is nobody living there. This flat is being rented just on Airbnb. Okay, so those are some examples on how to use data to analyze cities. So as a conclusion, think about what if every time we open a new restaurant or a new shop, we took into account the gravitational laws that are operating on the universe and that we have demonstrated that are also operating in cities. Or what if we design cities and streets not based on some great architect which thinks, okay, people will move around here in that way. What if instead of designing cities that way, we design cities following the mechanism that our brain is pushing us to do when we move around a city? Or what if we use all this huge amount of data to understand how people move, how people behave, how people live on cities, and design cities based on this knowledge? So at the end is, what if citizens, companies, or policymakers were more like Amazon, Google, or Netflix? So always ask yourself, what would Amazon do when facing a problem? Thank you.